So we're going to have a look at a few questions from exercise 8.1, starting with question 6, which involves solving a series of trigonometric equations. We're starting by solving this equation here in the range theta is between 0 and 180. So this is 6 part 1. I'm going to start by expanding the left-hand side of this. So using our compound angle formula, we've got sine 45 cos theta minus cos 45 sine theta equals cos theta. So start by expanding. Now we have some values that we can then substitute in. Sine and cos of 45 are both equal to 1 over root 2. So we have 1 over root 2 cos theta minus 1 over root 2 sine theta. You may also have root 2 over 2. And this equals cos theta. I'm now going to collect all the terms with cos theta over on one side. So 1 over root 2 cos theta minus cos theta, and then we'll move anything else over to the right-hand side. I'm now going to multiply across by root 2, which will make this look a little bit tidier. And then we're going to factorise on the left-hand side. So we have cos theta 1 minus root 2 equals sine theta. Let's divide both sides by cos theta, which leaves us with 1 minus root 2 equals sine theta over cos theta. And we know that sine theta over cos theta is tan theta. So this gives us tan theta equals 1 minus root 2. And we can then find theta using arctan. Now this gives me a principal angle of negative 22.5, which is of course not in the range theta lies between 0 and 180 degrees. So I either use the cast diagram or I use a trigonometric sketch graph to find the angle that I do want. So remember, the tan graph has an asymptote at 90 degrees. And then there's a section of the graph here. So we know that there's an angle of negative 22.5 here, and we want to find the matching angle, which is over here in range. So that angle, we know that this gap is the same as this gap here. So the value of theta that we want is 180 minus 22.5, which comes to a value of 157.5 degrees. So, question 6, part 3. Let's work through this equation here. We've got to expand using our tan compound angle formulae. We've got tan 45 plus tan theta on the left-hand side over 1 minus tan 45 tan theta. On the right-hand side, we have tan 45 minus tan theta all over 1 plus tan 45 tan theta. Now tan 45 is the same as 1, so that gives us 1 plus tan theta over 1 minus tan theta equals 1 minus tan theta over 1 plus tan theta. Let's cross multiply to simplify this. So we've got 1 plus tan theta squared equals 1 minus tan theta squared, and let's expand. So 1 plus 2 tan theta plus tan squared theta equals 1 minus 2 tan theta plus tan squared theta. Now the tan squared theta values cancel, so we've got 4 tan theta equals 0, because actually the 1 on either side cancels as well. So this tells us that tan theta equals 0, and then in the range 0 to 180 degrees, we have theta equals 0, theta equals 180 degrees as well. So 6 part 5. Let's expand the right-hand side using compound angle formula. Cos theta, cos 120, minus sine theta, sine 120. And we can fill in the values for cos 120 and sine 120 as well. So that tells me sine theta is equal to negative 1/2 cos theta minus root 3 over 2 sine theta. Let's collect the sine terms on the left-hand side over here and leave the cosine term on this side on the right-hand side. And now we need to factorise, so that gives us sine theta, and then in brackets 1 plus root 3 over 2 equals negative 1/2 cos theta. Now to simplify everything, I might multiply across the whole thing by 2. So that gives me sine theta, 2 plus root 3 equals negative cos theta. I'm going to divide by cos theta. So I've got sine theta over cos theta on the left-hand side. And I'm also going to divide by 2 plus root 3. So on the right-hand side, I've got negative 1 over 2 plus root 3. Now, sine theta over cos theta is tan theta, so I then end up with tan theta equals negative 1 over 2 plus root 3. We can then use arctan to find a value of theta, and this gives us negative 15 degrees, which is out of range. You must then use the trig graph of y equals tan x or the cast diagram to find the correct values. So here's a sketch of the graph y equals tan x. And here's the first answer of negative 15 degrees. The next answer symmetrically is over here. And then using the symmetricality, you can see that that distance there is the same as that distance. So the value that we're going to give is 180 minus 15, not minus 15. Be very careful when you do this. And you get 165 degrees as your answer. So question 7 part 2. Is another trigonometric equation, and the range of values of theta given is 0 to pi. Use the compound angle formula to expand on both sides. So cos theta, cos pi by 4, plus sine theta, sine pi by 4, equals sine theta, cos pi by 4, minus cos theta, sine pi by 4. Now, cos pi by 4 and sine pi by 4 take the same value of root 2 over 2 or 1 over root 2, depending if you've rationalised or not. So we can substitute in, like so, for each of these. And then, interestingly, we can see that this term and this term are identical, so cancel from both sides. And we can then multiply by 2, so we're left with root 2 cos theta equals negative root 2 cos theta. We can divide through by the root 2's, collect the cosine terms on the left-hand side, so we have 2 cos theta equals 0, cos theta then equals 0 itself. And then from here we can use arccos to find our value of theta between 0 and pi, and this is theta equals pi by 2. So here's the next equation. Part 7, part 3, 2 cos theta minus pi by 3 equals cos theta plus pi by 2. Let's expand on both sides using the compound angle result. So we've got 2 cos theta cos pi by 3 plus 2 sine pi by 3, and the 2 is of course in both parts just the 2 from the start over here. Now on the right hand side, what do we have? Cos theta cos pi by 2 minus sine theta sine pi by 2. Now let's substitute in some values. We know cos pi by 3 is equal to 1/2, so this term here all simplifies down to cos theta. We know sine pi by 3 is root 3 over 2, so all of this simplifies down to root 3 sine theta. On the right-hand side, we know cos pi by 2 is equal to 0, so this term disappears. Sine pi by 2 is equal to 1, so on the right-hand side, we simply have negative sine theta. As we've done previously, let's collect sine terms on one side, cosine terms on the other side. So if I collect cosine on the left and sine on the right, I have this. I then need to factorise the sine from this side over here. Lots of different ways of doing that. Negative 1 minus root 3. We could take the negative outside. I'm going to leave it inside the bracket. Divide by cos theta. So we have this. And then divide both sides by negative 1 minus root 3 as well. So on the left-hand side, we have 1 over negative 1 minus root 3. On the right-hand side, we have tan theta. Now, if we use the arctan function on our calculator, or tan minus 1, we get theta equals minus 0.3508, which of course is out of range. So we need to find the value of theta that is within range, either using cast or a tan graph. So again, we can use the symmetricality of the graph to find our value, which is over here. The pink gap is the same, so theta is equal to pi, take away 0.350. Remember, don't subtract the negative value, because otherwise you will get a value bigger than pi. This gives us 2.7907, which is the only value within the range 0 to pi. So this is 2.79 radians to 3 significant figures. So question 10 is all about small angle approximations. Let's start with the first part of question 10. We've got to expand this first of all. So we've got 2 cos pi by 3 cos theta minus 2 sine pi by 3 sine theta. Now, cos pi by 3 we know is equal to a half. So the first part simplifies to cos theta. Sine pi by 3 is root 3 over 2, so we end up with root 3 sine theta. Now, if we remember our small angle approximations, we know that cos theta is approximately 1 minus a half theta squared. Sine theta is approximately theta. So this then approximately becomes 1 minus a half theta squared minus root 3 theta. So question 10 part 2, we've got to find the small angle approximation of this, and alpha, which is this angle here, is not small. So let's expand using the compound angle formula. So we've got sine alpha cos theta plus cos alpha sine theta multiplied by sine theta. Now, we can then use small angle approximations for cos theta and sine theta here and here and here, but not for sine or cosine of alpha. So this then gives me sine alpha multiplied by 1 minus a half theta squared plus cos alpha multiplied by theta, all multiplied by theta. So this is then equal to theta sine alpha minus a half theta squared sine alpha plus theta cos alpha. Now, let's expand the brackets. So we get theta sine alpha minus a half theta cubed sine alpha plus theta squared cos alpha. Now, in the question that we were told that theta cubed is small enough to be ignored. So we can exclude that from the rest of the question. So we can say that the final result is approximately theta sine alpha plus theta squared cos alpha. So next we have tan pi by 4 minus theta. Expand using the compound angle result first of all. So we have this. And then remember, with small angles, tan theta is approximately equal to theta. So this is approximately 1 minus theta over 1 plus theta. remember tan pi by 4 is equal to 1. So question 11, part 1, part A, we've got to use small angle approximations to simplify this result here. Before we do the small angle approximations part, I'm going to expand this part here. So sine pi by 6 cos theta plus cos pi by 6 sine theta using the compound angle result, and then sine pi by 6 here. Again, I'm still not going to use the small angle approximations just yet. I'm going to substitute in for known values such as sine pi by 6 and cos pi by 6. Sine pi by 6 is a half, so I've got a half cos theta. Cos pi by 6 is root 3 over 2. And then I've got subtract a half over here as well. Now, I can then use my small angle approximations. Sine theta is approximately theta. Then I've got a half bracket 1 minus theta squared over 2, which is the small angle approximation of cos theta, root 3 over 2 theta minus a half. Now, let's expand. So we've got a half minus theta squared over 4 plus root 3 theta over 2 minus the half at the end. This half and this half cancel, and then we can expand, multiplying by theta, and we get this result here. But remember, the question told us that theta cubed is small enough to be ignored. So that means we can take that out of the running, and the result is root 3 over 2 theta squared. We'll need that result later on. Now, 11 part 1 part B, 1 minus cos 2 theta. Now, a lot of people went wrong on this question. Cos theta is approximately 1 minus theta squared over 2. So if you're now finding an approximation for cos 2 theta, then you've got to replace theta by 2 theta in this expansion here. So that's 1 minus 2 theta all squared over 2, which is 1 minus 4 theta squared over 2, which is 1 minus 2 theta squared. Notice that's not simply the double of this value over here. You've got to replace theta by 2 theta to get the correct value. So that's 1 minus 2 theta squared, which simplifies to give us 2 theta squared. Now we can go straight from here into 11 part 2, which asks us to find the limit as theta approaches 0 of a very complex looking result. Now the complex looking result is actually the result from part A over the result from part B. So that is the limit as theta approaches 0 of, now the result from part A was root 3 over 2 theta squared, and the result from part B is 2 theta squared. Now, theta squareds cancel, so actually theta can approach 0 at any time here. Once the theta squared is cancelled, there's no values of theta left in this, which means the limit is root 3 over 4. If we did have a theta value left, for example, in the numerator, we'd have to then allow that to approach 0, but actually both the numerator and denominator only contain theta squared, which cancels anyway.